Section 9.4, Ellipses. By definition, an ellipse is the set of all points P in a plane such that the sum of the distances between this point P and two fixed points called the foci is a constant. So imagine for a second that we have two tacks somewhere in a board, and we have a piece of string, one piece of string, and each end of that string is attached to a tack. And then somewhere between, somewhere in the middle of that string, is my tip of my pencil. And as I pull those strings taut, holding on to each of those tacks, and I trace it around, I will form an ellipse. And so these foci, are determined by a squared minus b squared. But we don't know yet what a major axis is and what a squared and b squared is. We'll learn that in just a second. But one thing to keep in mind is that our a squared is always going to be our bigger denominator. The other thing that you need to keep in mind is that this definition, or this factor of a squared being the bigger denominator, is only going to be the case in an ellipse. So when we get to hyperbolas tomorrow or in the next lesson, our a squared isn't necessarily the bigger one. Our b squared, on the other hand, is always going to be then our smaller denominator. So let's take a look at what an equation of an ellipse could look like. The general form of an equation of an ellipse, if you notice, my a squared is under my x, so my bigger denominator is under my x term, will tell me that this is elongated along the x-axis. So to graph one, the first thing we need to do is graph our center, which is at hk, and we should be familiar with this whole idea of hk, the number that's being added or subtracted to our x-coordinate, and the number that's being added or subtracted from our y-coordinate. So we're going to graph that. And then my a is always the value that's underneath my x. I'm going to move that parallel to my x-axis. That will be my a in this case, because my a is going to be the bigger number. My b, well, in this case, since my b is underneath the y-coordinate, then I'm going to move that parallel to the y-axis, and that's going to be my b. My c, then, is always going to be moved along the major axis, or along the longer, bigger denominator. And remember, we find our c squared by a squared minus b squared, so our bigger denominator always minus our smaller denominator. Keep in mind that we have to be able to subtract and still get a positive number so that we can take the square root of it. Again, one thing to keep in mind is that the equation of an ellipse is always going to be added, and when you find the distance for your foci, you're always going to subtract in that equation. Now we have the general form of an ellipse elongated along the y-axis, and you'll notice in this case my a, my bigger denominator, is underneath the y-coordinate, and so therefore it elongates along the y-axis. We're going to graph these the same. The first thing we need to do is graph the center. Again, my h and k, the value that's in the parentheses with the x and the y. I'm going to move, in this case, since my bigger value is under the y, I'm going to move that longer distance parallel to the y-axis. And then my b, since that value is underneath my x, I'm going to move that parallel to my x-axis. My c still is moved along my longer axis, my major axis. And again, that's still found by c squared equals a squared minus b squared. So now let's do a few. In this first example, well, what is our center? Well, the opposite of what's going on with our x and the x in those parentheses. So x plus 3 gives us an x-coordinate of negative 3, and y minus 2 gives us a coordinate of positive 2. So then we're going to plot that value. Next, 36 is our bigger denominator. That's underneath the x. So our a is the square root of 36, because remember that's a squared, so our a is just 6. And we're going to move that, since it's underneath the x, we're going to move that parallel to the x-axis. So from the center, move 6 units to the right and 6 units to the left. 16 is under the y-coordinate, and again that's our b squared, so our b is 4. And again, that's underneath the y-coordinate, so we're going to move that up 4 and down 4. And then we can just draw in our ellipse. Again, as long as it's not a square or having sharp edges, just somewhat elliptical. So our major axis length, our major axis is what goes from one end of our ellipse to the other end of our ellipse. So keep in mind it goes from one end to the center and the other end to the center, and those are each distances of a. So my major axis is always going to be 2a. In this case it's going to be 12. Similarly, my minor axis is the shorter lengths of my ellipse, so from the top to the bottom in this case. And again, it's always going to be from one edge to the center and then the center to the other side. So again, it's going to be 2b's. In this case, it's 8. Now our foci. So remember our foci, c squared equals a squared minus b squared. My bigger denominator minus my smaller denominator. And I get that c squared is 20. Take the square root of that, and I get that c is approximately 4.5. So I need to move that in really the only direction I can move it, because if I were to move it the other direction, my foci would be outside of my ellipse, and that just can't happen. So once I plot them, I can determine that the coordinates are 1.5, 2, or 1.5, 2, and negative 7.5, 2. And we're done. Now, we can't really graph this one yet. It's not really in graphable form. First of all, it needs to be equal to 1. Not 144, so how do we get it equal to 1? No, we can't subtract 143, but we can divide both sides by 144. So 16y divided by 144 gives me y squared over 9, plus 9x over 144 gives me x squared over 16. 9 1/44 is 1/16, equals 144 over 144 is 1. So that's the form of our equation now. So what's being added to the x or added to the y in parentheses? Well, nothing. So my center is at 0, 0. I can plot that. And now my bigger denominator, 16, is underneath the x. So the square root of 16 is 4. So I'm going to move along the x-axis 4 units in each direction from the center. My smaller denominator is 9. It's underneath the y. So my b, square root of 9, is 3, and I'm going to move that along the the y-axis. And then I can draw in my ellipse. Again, the length of my major axis is from one end to the center and back to the other end, so 2a is 4, and my minor axis, which would be 2b, is going to be 6. And now my foci. Again, my foci is c squared equals a squared minus b squared. My big denominator minus my small, and I get 7. The square root of 7 is approximately 2.6. So again, moving along in the x-axis direction, since it's longer in the x-axis direction. And then I can identify what those points are, 2.60 and negative 2.60. This one's nowhere near any kind of graphable form. We do have an x squared and a y squared, but you'll notice that we also have an x, which means we're going to need to complete the square on the x, and we also have a y, so we're going to have to complete the square on the y. And while we're at it, we need to get it equal to 1, so let's get that 45 over to the other side. So while I'm getting the x's together to complete the square on the x's, I'm going to factor the 4 out. So I'm left with x squared plus 6x. I'm going to leave space to complete the square. Plus y squared. There's nothing to factor out of the y squared, so it's just going to be y squared and minus 10y. And I'm going to leave space to complete the square again. And subtracting 45 to the other side, I get equals negative 45. So half of 6 is 3. Squared is 9. So I need to keep my equation balanced, so I need to add 9. No, watch out. That 9 is inside the parentheses, so I actually need to add 36 to the other side. Be careful of that. Half of negative 10 is negative 5. Squared is 25. There's nothing in front of the parentheses other than a 1, so I'm just going to add 25 to the other side. And now I can write these in factorable form, or factored form. So 4 times x plus 3, don't forget the squared, plus y minus 5, and again don't forget the squared, And I add all those things together on the other side, and they should add up to 16. So remember, it needs to be equal to 1, so I need to divide both sides by 16. So I'm going to divide 16 into both of those terms. X plus 3 quantity squared, and 4/16 gives me 1/4. And then I have y minus 5 quantity squared, and then I have 1/16 gives me 1/16. And then don't forget that it's equal to 1. Students always forget that it's equal to 1, but it must be equal to 1. And that's my equation. So my center, the value that's in the parentheses with the x, -3 and 5. My a is not 4. My a is 4. My a is 4 and my b is 2. Keep in mind your a is always your bigger denominator, so the square root of 16 is 4. So I'm going to graph my center at -3, 5. And then again, since my 4 is underneath the y, I'm going to move up 4 and down 4, so this is going to be a vertically elongated ellipse. And then I'm going to move 2 on either side for my minor axis, because that 4 is underneath the x, and the square root of 4 is 2, and draw on my ellipse. My major axis length, the length of my ellipse is from end to end is 8. The minor axis is 4. And now I need to find my foci. So my big denominator minus my little denominator gives me 12. So C is approximately 3.5. Since the bigger denominator is under the y, I need to move my foci parallel to the y-axis. So up 3.5 and down 3.5. And then I can determine what those coordinates are. So -3, 8.5, and -3, 1.5. It wouldn't make sense to graph them outside, because if I graph them outside, they would be, or if I graph them along the x-coordinate, they would fall outside of my ellipse, and we can't have that. Finally, example 4. Find the equation of the ellipse that's elongated on the y-axis with foci at 3, 4 and -5, 4, and a major axis with length 12. Well, if we were to go ahead and graph these, we would see that this isn't worded right. It's actually elongated on the x-axis. So if we go ahead and graph what we know, we see where our foci are. And keep in mind that your center is halfway between your foci. So we could find the midpoint of our foci, add the x's together, divide by 2, and add the y's together, divide by 2. And we get that our center is at -1, 4. Or if you've graphed them, you can say, well, my center is halfway in between, and you can plot them and then still determine that your center is at -1, 4. So we kind of have this skeleton idea of what an equation of an ellipse is, so now we just need to fill in what we know. So my center, I know the x-coordinate is at -1, so it's going to be x plus 1. My y is y minus 4. And then it's a major axis of length 12. So remember, a major axis is twice my a, so my a is 6. Therefore my a squared is 36. Since this is elongated along the x-axis, the 36 goes under the x. And next, how can I find my b squared? Well, I know my c squared and I know my a squared, so I can use this handy-dandy formula. So my c, the distance from my center to my foci, is 4. So c squared is 16 equals 36 minus b squared. Solving this for b squared, -20 equals -b squared, so positive 20 equals positive b squared. And I don't even really need to know what my b is, because in the equation I just need my b squared. So my b squared is 20, and I have my equation. Please make sure if you have any questions, you come to class with them, and we'll see you tomorrow.